That was
Just
a very
explaining it now.
interesting. That was a very interesting sentence. That's right.
Oh, okay. We're recording now. So yeah, we're going to use a abstract class interface kind of combination. So the abstract class will define the will lay out the methods. We'll lay out the methods. We'll let us have some fields in there, some abstract fields and stuff, so we know what fields are available to the methods, and so that those fields can be inherited by the child classes. While the interface will let us know what kind of method we have and how to interact with the system and what methods are available. So we will have certain things available to us. And so using a combination of that, we should be able to then pull what we need. I'm still trying to make sure I got this right. I actually want to do, we're gonna do a mini test first to build a very small item where we build a small interface, a small class, a small abstract class, and a small child class, and then make sure we can understand how those are utilized. Can we utilize those the way we intend to, if that makes sense? All right. So still and my biggest thing here is to still make sure, do we get the outputs that we want? And we do want to run we are going to be running methods. And that's kind of the biggest thing for interfaces. Interfaces are all about the methods, all about static items. Any fields you put in there are supposed to be static, which doesn't work in what we're trying to build. So I'm going to take what we have, refactor it into a correct interface abstract class system. So you guys can see that. That way, if any of you want to update some of the interfaces or maybe make another interface in your drag race class, you can work on that. On Thursday, we'll review those, take a look at what you guys built for your drag race. So I'm going to probably, if the due date is Tuesday, I'm going to change it again. I can't remember if I did. I think I did the due date is Thursday. I think I did that. So for the drag race. So I'm going to look at your guys' work on Thursday. You'll do a demo day that day. Whatever you have, again, doesn't need to be perfect. I'm looking for the wooden plane. Always remember that. Back of your head, wooden plane. I don't need fancy. I don't need Luxor unless you feel like you do it. Unless you can pull it off, go for it then. But all I care about is that wooden plane. So if you got that on Thursday, you've at least done well enough that we can move forward. After that, next week is card games. Go ahead, Jim.
I'm just trying to figure out where I'm in the drag race where I'm putting my interface. That's the only thing I have a
and
question
so I'm hoping
about.
that maybe this example might give you some other ideas. Instead of trying to think of just a single, like an interface on its own, you could realize that maybe an abstract class that has children classes could be turned into an interface. Like the engine could have that, where you have the abstract engine, two types of engines, but then you have an engine interface that tells the car how to interact with the engine. So the car knows how to work with the engine without knowing any of the details of the actual engine itself, not knowing any of the fields. It doesn't know any of the fields that are there. It doesn't know what the methods are doing. It just knows, hey, if I have an engine, these are the methods I have access to as a car, and these are the only methods I care about too. That's something to keep in mind that an interface can do. An interface, you could have two types of interfaces working with the same class, where one is utilized by one system and one is utilized by another system. For example, in this case, just go back to the car example, the dashboard or the console of the car. So the dashboard of the console of the car works with the engine in certain ways. How you turn it on, turn it to standby, those types of things. Whereas the gas system will interact with the engine a different way, where the fuel system will work with the engine a different way, or how the engine and the drivetrain work together, how those interact with each other. They work together differently.
I was thinking more of what I was kind of thinking was interfacing, meaning with the different vehicles, like a plane would have a completely set of different languages and how it would act with the engine, and a car would be different. All those would be plugged in as an interface, like it would update to what it's supposed to be, and kind of thing.
Yes and no, I could see that. And really for that, like I don't know, I feel that for me, I wonder if like does a plane and a car interact with a engine differently? I feel like it turns it on, accelerates, and then does it, and then I don't really think technically, I would say,
well, I was just thinking,
like the car doesn't, or the vehicle doesn't decelerate with the engine. The vehicle decelerates with the brakes, but it does tell the engine, don't pump, calm down, relax. So
like, miles per hour, like somewhat of a console maybe, because it was like airplanes go by knots versus, or a boat goes by knots versus a car miles per hour, like different things like that. I was trying to think somehow, like not necessarily just doing a console type interface, but I was also trying to figure out how to use the unique parts of the vehicles as part of the interface. That makes
sense. I like the idea of it and concept of it. The main thing that's again different on that is, again, I don't really think the engine is in charge of the speed. The engine will change the speed, but the car is what's actually going. and the car has the speed. And you technically would think that if you really wanted to get again, this is where we start getting a little more beyond it, and knowledge of the real world can help. The speed of a car is based on the odometer is based on the calculation of the RPMs of the drivetrain or the wheels versus its map that it has set in itself. So as long as the odometer only works accurately if you use the tire size that is recommended. So that way the RPMs calculate correct. If you actually put smaller tires or larger tires on it, your odometer is actually inaccurate, from what I know, my understanding of how that stuff works. So if you take a car that's supposed to have like 18-inch tires and you put 24-inch tires on them and somehow they fit in the well, your RPMs, your speed is not going to match the odometer. I don't know if it's how faster or slower. I actually don't know on that, but that's too much for me to be aware of, but I do know that does change it. What's that, Colin? What's TIL?
So I learned today.
Oh, I learned about tires and miles. Okay.
Today I learned.
I'm not used to an acronym with the I, with a single letter being part of the acronym. With TIL, what? Till what? Hang on, I suppose I try my best to know all the internet abbreviations. Like I know TLDR and all that stuff. I didn't. Why did
that's a whole Reddit section, TIL.
Yeah, and now you just mentioned it.
Today
as soon
I learned,
as you
yeah.
told me what it is, it makes sense. Like, oh, okay, yeah, I know what today I learned
It
is.
took me the longest time, the MFW, and I was like, what the fuck is MFW? And it's like my face when X thing happens, you know. It took me the longest time.
I'll do a TIL of an acronym. So I always knew that FTW and F the world, but today I found out for the win is another meaning for it.
For the win.
Like,
okay,
that's a much better way of saying it.
What? I didn't know about
there's more meaning thing for the win. That's the only one that I knew.
Oh,
yeah, exactly.
FTW.
I'm with everything.
F the world.
Oh man.
So it's like, fuck, F this. We're putting explicits right in the beginning of the class. Great.
Yeah, especially Sergio. I'm counting them.
But,
hey man,
yeah.
He's been drinking that soy boy, you know.
Right to it. But yeah, we're gonna be interesting. So and actually the fun thing about this is like I definitely recommend like you guys can definitely get together on non-class days and really just discuss structure, discuss program structure, class structure. How would you define these things? And without even building them technically, just discuss what could be considered classes, interfaces, abstract, how would this interact with that? That can be a really enlightening discussion to have with classmates and just to discuss how would you maybe build something in the real world. Taking a real world object, just looking around your house. Hell, a simple one that you guys could even practice could be even a clock. How do you interact with, like we have a clock with the second hands and stuff like that? How can you do those? You may have a digital clock or a physical clock. What are the ways you might implement those? What classes might exist? What interfaces might exist, et cetera, et cetera. So those are some things that can be really interesting to think about. You know, ATMs, automated. Hell, even think about like a self-driving car on a high level system. Like talk about a lot of these. Sometimes just discussing things in a high level system. Maybe thinking like, oh, if I ever wanted to do a robotic Instacart thing where there's a robot that goes around to pick the items for the Instacart, how could we do that? So this can be really interesting discussions you can have that can help you to understand how to design and structure these things. So just talking about the cars and interfacing with engines and drivetrains and tires and all these individual parts that work together, what parts need to know the details of everything, right? How directly coupled are they? And where does this information come from? It can be just a fascinating discussion. It can help you to better understand how to build things. And once you start learning how to break these items down, when you go to other items, you'll learn how you'll better be able to break down those more complex items. So you start breaking down smaller items that are maybe easily accessible to you. And then when you start thinking of more abstract items, like part of the reason why I was able to kind of come up with an abstract concept for the drink dispenser, because I've done a lot of this breakdown of things that are nearby me. And now I can go and look at things that aren't really mine, that I don't have ownership of, and can really just think about them in a weird way. Because I have that kind of programmatic kind of thought process now. I've developed that over a couple of years now. So those are some great things you can do to really just exercise that it's hard to say, like, I don't want to say destructive mind, because you're kind of pulling it apart to see what it's looking like, but it kind of seems destructive. Like we're taking something that's together and pulling it apart to see how it works and how would we make it work? How would we build it? And what objects and systems exist? So, but yeah, with the car, there's a lot of different things you do. And sometimes what we need to do is just simplify those items, which is what I'm saying. Like the car, it can manage the speed. We're not going to build a tire interface and a drivetrain interface. We're not going to build the RPMs versus tire size calculation. It's going to let us know what our speed actually is, right? If you want to do that, go for it. But we kind of don't need that in the programs we're building, do we? We're not simulating tire rotations. We're not dealing with turning or anything like that. So we don't need to worry about that stuff. So that's kind of not something we need to really deal with. And so we can simplify that by just saying, hey, the car knows its speed. We understand the car knows its speed because it's getting it from the tires, but we don't need to know that part of it in order to utilize it in our program, right? We abstract things away and just say, you know what? The car knows the speed. And that's kind of the idea here. But once you have the rest of the system built, you can always take that a step farther and start expanding on it. You can say, well, now that I have this system built, let me actually dig into how the car gets the speed and make it more realistic. But again, if you try to build the whole car at once without designing smaller pieces first, you're gonna explode. It's gonna be too much to deal with. So yeah, let's take a look at this interface abstract class concept. I think that's gonna benefit you guys a lot. It's gonna help you maybe come up with other, if you've been struggling with coming up with an interface other than just a language-based interface right now, this might help to give you an idea for some others. Like I said, from talking with the engine, talking with the vehicle, maybe if you added other classes like tires or brakes or something, or a passenger, you could work those into this too. So with this example, maybe you'll have other ideas. Like I said, your goal is to do whatever you can tonight, into tomorrow, into Thursday for demo day. I'm hoping to keep this lesson to about 1.5 to 2 hours, so you can actually have the rest of the night to work on your drag race. That's my goal. All right. Sound like a plan? Cool. So you get right into the code. You guys are gonna code along. We're gonna be renaming. We're gonna not really rename. We're gonna create a secondary package with similar class names, so that way we can reuse the code. We can copy paste some of the language data over, because I don't want to have to retranslate everything. But let's get into it. Let me go ahead and open up IntelliJ quick. This button. Let's share. There it goes. Move you all over here so you guys on the screen bigger. I was going to try opening up the chat window from the beginning so I don't miss things like Colin and stuff for everyone else who does that. Also, let's see what I can do. I'm going to open up the breakout rooms for you, Christian. If you want to jump over, you can just hang out and watch if you want. Feel free to until Evan gets here, but I'll open it up so you can at least head over if you want. If I get a minute, once I finish up the lesson, I might try to pop in if you're still in there. Sound good?
Yep.
So great. Open the rooms. All right, it's available. You can jump in as soon as you want. You can hang out and watch and ask some interesting questions that the other students may not think of. Cool. All right, so first things first, let's touch again on what we ended up building that was like, we'll make this work even though it's not what we wanted. So we created a UI that has the logic in it. So the UI has all the logic. How the system is going to print is going to use Lang methods in order to print out the messages. Timer's here. Also, timer dropped for a second there. We then created a language interface that has a bunch of methods that are really just data types. These were technically just ending up being fields that we ended up using. And our English items just ended up returning those items. So I'm going to change this up a bit. I'm going to create a new package so we can reorganize stuff. Package. Let's see, what do I want to call this one?
Packages on a grocery store.
What's that? Yeah,
Where's-
put it in the grocery store. So, yep, another grocery store package. We're going to do console with a K, just that it's separate. And the goal is later on, we'll refactor the two so that console with a C will become console with a K and console with a K will become console with a C. So this way we can use the same names here or similar ones. First, we're going to do is we're going to start with the abstract class. And this is going to be UI. So UI is going to be our abstract class now. here. Final string. And I'm gonna,
To put an abstract in the class.
oh, thank you. Do that. Yo, put that in there. Abstract public final string. There's gonna be the array one called menus. So that, and then see what's being yelled for. Yeah, might not have been initialized. That should not be a problem here unless I have to make them static in the abstract class. Remember, the abstract classes do not need to be, we're gonna get rid of the final actually. So I think that's part of what it's upset about, is that finals want to be defined at some point, and technically we're going to define them in the child class. And the child class, I think that's where we're gonna make them actual final. So in the abstract class, it's going to be public without being final, and then the child class will set the final statements. That way, as soon as it's set in the child class, it can't be changed anymore. So by not putting final in the abstract class, we're saying that the children can set it. So we're clarifying that the child classes that implement this abstract class or inherit from this will be able to set the value. But in that child class, we'll then add the term final to make sure that that's the final version of it. Does that make sense? By giving it this title here, the capitalization here, we're hinting that we want this to be finalized at some point. That this at some point should be constant, even if we don't utilize that constant system or that final system. So I'm going to actually take advantage of this and just kind of copy this item here, or copy the public string. So I don't want to have to keep retyping that over and over and over again. I'll go a little quicker with this, so feel free to do that. Paste. The next one is going to be the types. Oops, I like that. And that's the curly bracket. So let's put that back.
You need the parentheses?
Need those. Nope. That's why he's yelling at me. That one. We're going to have a bunch of just standard strings. It's going to be easier. So paste and then the name. And now I can, it's because I have that copy now, I can also just leave my caps locks on. That's part of the reason why I did it. So another trick, by the way, just so that you guys can know that there is a concept known as name alignment. You see this more in other languages like Haskell and stuff, and some of the more console-friendly languages. But there's this concept of, again, white space is optional. White space is ignored by most programming languages. And so I could do this if it makes more sense to look at it like that, where all the field names are lined up. So you feel free to add blank spaces that all the field names line up with the field names. That is another technique you can use. Of course, base that on your company and see if they're okay with it. Or honestly, I've heard some companies actually, when the very first time they see this, they end up liking it and want to implement it. So that could be a fancy thing you can show off. Like I said, there's certain languages that do implement this. It's not common in Java, but it is something that I've learned that I've actually started to grow on me, seeing in these other languages, that I'm starting to bring it into my JavaScript coding. So I'm going to showcase it today, but we're going to go back to the standard typing when we go back to, starting on next week. So I'm just going to showcase it today so you guys can see it. I will say though, as a teacher, if this looks better for you guys as students, let me know. If this is easier for you to read as students, I will go ahead and type this for you guys as students, as long as you can make sure you recognize this is not standard Java practice, but it can be something that companies can like. And again, every company's standard practice is different. That's why we have something called a style guide. All companies have a style guide.
Oh, I'm all for symmetry and style, so I like it already.
I like it already too, but it just ends up being tons of spaces if you do like a list or something where you have like where a string is, it's just long and trying to like line them up. But as long as like strings are like this, like they're all kind of the same. I like doing it this way too.
Yep, and that's again why sometimes people like it, sometimes people don't. So it's something that, again, you really just need to see what the company feels. If they like it, go for it. If they don't, stop. And I misspelled prompt.
I'm sorry, I forgot. Why are you doing everything on caps lock?
So these are all going to be static values, constant values.
So every time there's a static, you should use caps lock for the variable name.
For any constants, yep. Anything that's a constant value that is not supposed to change, This way, if you
Okay.
don't have the IDE protection like final on there, you know that if you're doing an assignment operator, you're doing something wrong. You should never be using an assignment operator on the right side of a product of a all caps variable. It's a common practice. There's no requirement of it, but almost all developers recognize this concept that if you have a variable that is all caps with underscores in between, this is supposed to be a constant value and should not be modified. You should
Alright.
treat it as immutable, even if the language doesn't have constants. There are some languages out there that do not have constants. And there's also some languages out there that just all things are constant. But anyway.
Just to just to go on the side point though,
Go
if
for
you
it.
do an enum, you'll notice a lot of enums are all capitalized because they're all constants.
Oh yeah, they don't change at all. Yep.
Yeah, they don't
Same
change at all.
concept.
So
If something is not supposed to change or can't change, that's commonly made all caps, commonly. It's not set in stone. And it's also something that's a little more, there is always there's some wiggle room in there in some areas. Like I know that JavaScript, you guys learned about the const variable name and you did use that a lot probably for certain things. But if it's a constant in the sense of like a local variable that's only going to use once, don't worry about that then. Because it's something that is like, it's only constant in the sense of like, it's short-lived. It's not a constant value that doesn't change. One of the biggest examples of that is like, when I say, hey, how many inches in a foot? What do you tell me? Do you not know?
12.
13.
Okay, thank you. You're right. But, and if anyone was to say a different number, you would look at them like they're insane, right? Hopefully. If I
Hey,
say,
I
yeah.
come from somewhere that we use only metrics, so
Ah. Well, again, we talked about that. How many ounces in a pound? That's not metrics,
Yeah.
is it? Is that metrics? That's metrics.
No.
Right? Yeah. No.
that's not.
How many meters in a kilometer?
1,000? Isn't
Yeah.
it?
Yeah.
Yeah,
Yep.
1,000.
Meter
Yeah.
to kilo is 1,000. Yep.
It's all rounded for meters. It's
yeah.
way easier.
Mhm. But these are the ideas of constants. They don't fluctuate. How many inches in a foot is 12. So you would have that would be the variable, just for the fun of it. Int. Inches to feet. Well, that's an idea of a constant. There is no questioning that value, that data, that should never change. It is a set in stone value, right? A constant that you get from something, while constant at that moment, could be dynamic. Those items don't need to follow the all caps syntax. Well, yes, you're not going to change that variable, not going to reassign it, since it's a dynamic thing that every time you check it, it could be something different. That's where I'm saying that this kind of fluctuates a bit. That's why when you talked about const in JavaScript, sometimes you use const to store the data from like the input from a user or store what you pulled from a database. Those, while yes, you're not going to change them after you get them, the value, anytime you scan that value, that variable, since it won't be the same thing every single time, that's not considered a constant. We're using them here because every time I do select prompt in a certain language, it's going to be the same thing every single time, right? There's never going to be a chance in the moment where it changes randomly. It really shouldn't. So that's kind of the idea. And again, all things I say, these are not laws. These are just rules and common practices. Paste. Next one is the product prompt. Next one is the cancel prompt. Yeah. Next one is the error MSGS. I'm actually going to move these parentheses, these array types to the top so that they're next to their other array types, so that all the arrays are next to each other. You don't have to do that if you don't want. Oh, this is supposed to be an array too, actually, now that I think about it. Product fields. Again, drink fields. More time. Sound good? So far, so good. All right. Now what we're going to end up doing, we're going to look at our C console UI. So the C console UI, the one we have here, we're technically going to bring in a lot of these settings. So we also know that there's going to be a store, but that's going to be private. Private UI, the constructor it will be. So you know what? The abstract class should have that. Go ahead. Yep.
Are you gonna be? I guess because I was 10 minutes late, but I was wondering, did you branch out today's work, or are you gonna do that?
Call. Let's do that right now. Actually, let's instruct that. So yeah, like I said, I'm actually glad that I did this right now. So I didn't do it immediately, so you can see how this works. So we talked about it a bit on Thursday, and what I want to start doing moving forward is doing all of our classes in branches. When I push it to a branch, that's a checkpoint in time of the end of a class. So if there's any homework assignments that you miss, you can just go to that branch, pull that branch down, and work on that homework. So do get status right now. We see that we have that new package console with the UIs inside of it, but it shows that we see this new file. If I was to commit it right now, that would make it part of the main branch. What I can do is at any time before I add or commit or do any other commands, I can branch it. Any changes will follow me to that new branch, because these are non-committed, non-tracked changes yet. No branch or no portion of Git is tracking my information. So they don't care what happens to it. They don't care if it disappears or goes away or stays. Until I track it, the current Git branch doesn't care about it. So if I make a new one, it's going to follow me along. So don't panic if you don't branch immediately. That's the first thing I want to make sure everybody here understands. So some people, past classes, I've seen that. People are like, hey, I didn't branch right away. I'm like, what's going to happen if I branch, or I don't think I can now. I'm going to lose this. Like, nope, you're fine. You git branch, okay, sorry, git checkout, my bad. So git checkout means we want to check out of our tree or our system this branch and bring it into the active, make it the active branch, the one we're looking at. So check it out, kind of like checking out from a library. I know that's kind of a dated reference now, but it's all good. Now we do get checkout with a branch that doesn't exist yet. So we're going to do the console. We're going to do the console with the K branch. Now I enter now. It says, hey, that there's no file by that name and there's no branch that name. So I can't do that. What I'm going to do -B is say, hey, make this a new branch. Whatever I'm about to type, that's the branch name, and I want you to make it and then switch me to that branch. So it's going to do two things. It's going to make the branch and move to that branch. So again. And now we see we are switched to a new branch called console. If I do git status again, yep. You'll see that, and it seems like it actually understood me. Oh, no, it didn't. Okay. And you see that it still has the same untracked items, and we didn't lose any code here. So now we're in a new branch. And so any code I do here will stick to this branch. What I'm going to do is I'm going to finish this abstract class. Once the abstract class is finished, what am I saying? Yeah. Once the abstract class is finished, we're going to go ahead and commit this, go back to the main branch so you can see that this code doesn't exist anymore. It only exists in the branch until we merge that branch to main. So I want you to see that process. And that's this way, when you're working on your projects from now on, whenever you're building something new, you can keep your main branch safe and always runnable. Your main branch should always be something that can run and can do stuff. Or at least it shouldn't crash, so to speak. May not always do what you want it to do, and do something that's fun, that's good, but the main idea is that the main branch should not be broken. If you're gonna have something broken, it should be a separate branch that's gonna be broken. If that makes sense. So let's continue on now. So in here, we do need in our UI classes, we do need to keep track of store. We store Evan's in. So I think Christian headed to his room. I don't see him in there, so yeah. All right, Evan, Christian headed over to his room already. If you can pop over when I finish here, I'll try to pop in and see how you two are doing.
Okay. All right. See you there.
Store. We also are gonna need a scanner, and now this can be an actual like set scanner, so we can actually make this normal. So we can do, and then these I'm gonna make these protected actually. We know that they're private here, but we do know the child class is going to need access to these. So let's actually turn these to protected. This one can be static. I didn't import that, so I do need to bring that in. So I was going to bring this back. But I will say scanner kind of throws that off, and that's where it's like, you know what? Some items, the ones that don't really line up with your nice neatness, can go down below. So with this one, we could bring up more, put that there.
That's
With
what I
this
was
one,
kind
we're
of.
gonna
That's
keep
what I was
down
kind
here.
of pointing out. It's like you
Yeah.
have these lines that are extra long that
Yeah,
we'd have to
I
go
will
back
admit-
and fix all that stuff out to even them up.
yeah. I will admit that in the Haskell system, if you wanted to keep doing it, you would actually push these all over. So they line up with the longest one. So do be aware that Haskell would have you do this. Right now, I don't know why the system is set to 4 tabs. I usually only set it to 2, or 4 spaces per tab. This is what Haskell would have you do. Bit annoying, and at the same time, you'd also do, these would line up too. So I would probably also push this over. This is probably what, yeah, this is what Haskell would look like.
Holy mackerel.
Okay, now it's too much work.
Yep.
yeah.
Because they have their import or import qualified, then they have the package name and then what they're importing. And they have the what's importing in one column, the where it's importing from in one column, and then the import or import qualified word in the first column. So they're kind of tabling it. So Haskell gets a bit excessive with it. I'm kind of trying to keep it a little more simplified for myself and just line up what I can and what matters to me. And I'm going to put it, I'm only going to put as much effort as I want.
The
So,
issue
I
is don't hit Control Alt L.
What does that do?
Well, that normally just cleans it up to Java to make it Java. Don't do it. Did you
Only
do it?
lose these spaces here, so it's not a
Yeah.
big deal. Didn't do anything.
It didn't do anything?
Window L.
Well,
Is
usually
that Windows?
Yeah, it cleans up.
Yeah.
It cleans up code. You could do
Cleans the code up.
You do code. Go over code. Then go down and it's a reformat code, and you could just reformat it, and it
Command
just will
Shift
make
L?
everything all nice and
Command
neat for
L.
you. But
Oh, there it goes. Yep, it did kill it. I can just undo though. There you go.
does Haskell actually add the spaces in to make it to look like it's supposed to?
Nope.
Oh, geez.
You have to do it yourself. Yeah. So that's what I'm saying. I'm only going to do as much as I feel comfortable doing, and then scanner is just going to be on its own. But I think I can fit language here. So I'm going to do, well, we don't going to need language now. So language, we're no longer going to be implementing this language field anymore. That's kind of the benefit again of this with the new thing. We don't need this language container anymore. So we have our scanner. We're going to go get the constructor now. So let's do public UI. Yeah. This dot store equal store. So again, this is one of the benefits of abstract classes versus interfaces. Abstract classes can have variables. They can set certain variables already. If they can set the logic. And that's one of the benefits of the abstract class. And all this stuff is inherited by the child. Now, the downside, of course, is that we've got to be very careful with our data types and stuff like that because they can be accessible otherwise. So, and these actually, of course, be protected, but it's fine for the moment. We might change those later. We'll see. Probably should have made those protected, but now that I'm looking at them. Anyway, we're gonna do this. We will create the setlang method later on once we know where that should go. We did it like this for the moment because we needed that with the current system we had set up. This may change depending on how we want to do it. So we're going to leave this here for the moment. Let's go ahead and do the welcome method. So I'm just going to grab this for the moment, copy and paste. I'm just going to replace this lang welcome with just welcome, like that. All good? Note that I'm not making these methods abstract. Why not?
Because the interface is going to take care of it.
Yes and no. The main reason I'm not making these abstract is because I don't need the child class to change these, do I? Or to define them. My abstract class is actually going to define the logic for the child. The child is just going to utilize these methods, and what the child is going to do is actually define the fields. So this is a different type of abstract class. You guys, the first abstract class we built together was where the that you did with Matt. He had you guys build a one where the methods were different for each one, and you had fields. And this one, we're going to touch base on the other concept where all the methods, or most of the methods, all the methods are defined, and it's just the fields that are going to be unique in each of the implementing classes. So by using that, we're not going to have to type any of these other methods again. All the methods are going to be inherited through the inheritance. What the interface is going to do, though, is let the main class, the store class, know, or main right now in this situation, it's going to let main know what methods I can run and how to control the system. And most likely in that case, all we're going to have access to is that we're probably actually going to be able to switch a lot of these back to private, because I know we switched a bunch of these to public for use in this system with the language console, all that stuff, but we might be able to switch a bunch of them back. This probably will be able to go static again now because, oh no, they won't unless these are static. Never mind. Right, because we have name, which currently isn't static, so that's fine. You know, shouldn't change it to static anyway. They're not going to be static because it is going to be dynamic somewhat, because the name will be different depending on the language of the child class. So
just go with it. It'll yell at you later.
Yep. It'll let me know. Yeah, let's do the next one. Display options. Let's grab this. Copy. Most of this is going to be a lot of copy pasting and then just changing some stuff up. So this one is just, we're going to leave it exactly the way it is. This one we don't change at all because this is just a reusable bit of code. Start's going to change a bit, I believe, because you have the lang in there. Grab that, put that in here. We're going to get rid of the lang again. Get rid of this. It's going to yell at us at the moment because we also don't have, can I get rid of multiple of these?
Yeah, you can. You can do a search replace.
Where is search replace in here again?
Just go like edit, find.
Is that the, wait, hold on, is that Control F? Nope, never mind. Wrong button. There it is, Control F or Command F. Find.
There you go.
Where's the replace? How do I bring that
You have
up?
to do replace though. That only does find.
Usually there's a drop down to make it to expand find to find and replace in most tools. Does it not have that?
No, because it
Edit.
usually has a find and find.
Oh, it's Command R. All right,
There you go.
fine. That's not R. That one. There it is. All right, cool. So I'm going to do lang dot. I'm going to replace it with nothing. We're going to leave that blank, and you're going to see it actually will remove those all. So replace all. We're also going to find this. No, I don't think we can do that. Well, can we do that? I think we can actually. Yeah.
Yeah, you can. You
Yeah.
just gotta
No, because it'll be the start as well. The starts will get removed as well.
well, yeah, but if you just go through them, you could just replace the ones you wanted to. But
I'm going to test. You know, I have an idea. I'm going to test it in the next one. I think I can just highlight the place I wanted to search through it then. So we're going to try that next. But let's go ahead and do our get int next. Let's grab that. I'm also going to clean this one up now. So I'm going to get rid of this catch. I'm going to get rid of the finally. Right, curly bracket back. Keep that there. Good. There's only one lang here, so we're not going to be able to test it. So let's get rid of that and that. Good. Now I get int happy, so the start is a little happier now.
What catch did you get rid of?
Error message one. Oh, I got rid of the other two. So it's just the try and the first catch that has the number format exception. So I kept the number format exception one.
Mm-hmm.
The other catch is gone, and I removed the finally comment just to clean this code up now. And since we have the branches now, you can always look later to see if you want to look at that stuff later again. But I want to clean up this code a little bit. With that, let's get the get string in. Put that in. Again, we got the one lang error. So get rid of lang, get rid of the parentheses, and we are good to go. I was going to get rid of that random extra space there for some reason. Go. That space there. I'm just cleaning up some spaces. Clean up the white space. All right, so we got string. Let's scroll down now. We got handle menu selection. I'm gonna bring that in next. This is gonna yell at us a bunch because we have a bunch of things missing. We're gonna comment. I'm definitely commenting out line 6 for the time being, case 6, because we don't have that. We aren't planning to build that right away. We want to make sure that everything else works as intended. We're gonna implement this, and we're gonna implement the English version first, make sure that works, and then we'll bring in the alternate language and we'll bring in the setlang method once we know that works. So lang, get rid of the parentheses. We have that. There's our handle menu selection. Let's bring in add product. Now we're going to test the search and find. So heads up, oh, David hasn't connected his audio yet, so wait on that. So I'm going to highlight first and then I'm do the search here and do replace all. Feel like that could do it. So you know what? I'm going to do it again with the parentheses. I'm going to hit the replace all, and if it doesn't work, I'm just going to hit undo. So you guys might want to wait before you do this with me. Oh, no, it gets rid of the selection. Dang it. Oh, in selection. There we go. That's what I was looking for. So by using this, and I want line 88 out of there. Hold on. Highlight this area, right? Yep, because that'll give me those. You can see that it's highlighting the ones it's going to replace. 1, 2, 3, 4, 5, 6, 7. Ooh, but though, hold on though. We do want these here, these here, these here, and these. Oh, we don't want those. Never mind. These are all we want. Yeah, we want to highlight all those. Right. Yeah.
We want to get drink details though, because those are
Right.
methods.
These are methods, so we don't want those selected. So I'm going to do this one manually, and then these
You want
4
the
I will
one?
highlight.
Oh yeah, you do want the one.
Yep. So these 4 I'm going to highlight. I'm going to make sure that this option here on IntelliJ in selection is enabled. Place all. There we go. There's a little trick for you. Using the find and replace, you can highlight what you want to replace, and it will only remove the stuff within the selection. Cool. That's clean. So now our add product's happy. Let's do the get drink details next. This is going to be a fun one, so let's go ahead and highlight all lines. I'm going to get rid of lang first. We'll do the parentheses first this time. Make sure none of them are methods. No, 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 and no. So you can see all of our parentheses that we're targeting are following a lang variable. So I'm going to go ahead and replace all. Replace that with lang now. Lang dot, sorry. I don't know why it needed to highlight again, but sure. Place all again, and we're done. So a little bit faster this time instead of what we had to do yesterday. A little faster to remove them all. Give everybody a minute to catch up.
Wait,
While you're catching up, so David, just so you know what's going on, I wasn't happy with the implementation I did on Thursday. So what we're doing here is I'm going to showcase a different type of what's called a interface and abstract combination. So we're going to use an abstract class for the logic and to define or to declare the fields. The child classes that inherit from the abstract class will define the fields and also pull in and inherit all the methods. The interface will just define what methods are available to classes such as main and store. Sound good?
Okay.
Cool. A lot of these also probably are going to need to be made protected. I forgot. I'm doing a lot of private in here, but we'll hold off on that until we get to. Actually, no, that should be fine. So the child class isn't accessing those methods, so that's actually fine. Now that I think about it, never mind. The child class just needs to be able to run start as well, or have access to start, so that start can be run from main. We should be fine, actually. Never mind. Yeah, anyone need any more time? Awesome. All right, let's do the next one is the fruit details. You do the same shortcut again with the font search and replace. So I'll highlight. Place all for lang. And 2 parentheses. Place all. Done and done.
wait, which one you do the parentheses and the replace for
Get
nothing?
fruit
Right?
details. Yep.
because I'm trying to make that work. So you did the line first.
So I highlight the section of where the stuff I want to find and replace is. I
Okay.
come up here and then I make sure that this option on the right here is enabled in selection.
In selection. Ah,
Yep.
that's what I wasn't doing.
Gotcha. Yep.
But then it's doing one at a time. What the heck?
You need to highlight the section and then you click replace all.
Replace all.
within the section.
I'm hitting replace. My God.
All good. No worries.
Okay, cool. And then you did the parentheses, just 2 parentheses, and then replace all.
Make sure the section's highlighted.
Beautiful.
Cool. If you ever do make a mistake and don't have it highlighted, just remember Command or Control Z. Undo is your friend. All right, we're going to bring over display products. That should just come over as is. We shouldn't need to make any changes because we're not referencing Lang at all. And it is happy, so we're good. Let's do select product now. Again, I don't think we actually have any Lang in here, so we should be good to go. Let's find out. Yep, it is happy. Let's bring in throwaway products. That one, I do believe we have at least a couple Lang. Yep, we do. Any methods? No methods. We're just going to highlight those 3 lines. Replace all for the parentheses. And then Lang. And I got an extra parenthesis there for some reason.
End period.
Oop, I forgot the period. Undo. Do that again. Period. Easier than me trying to just do the periods. We have the dots in the system.out.println line. Don't want to deal with that. So that one works now. That one's happy. Last but not least, our cell product. Paste that in. Same thing. Highlight the 3 lines. Place all on the Lang. Parentheses and replace all. And there we go. So let's scroll up, make sure we have no reds. So we want to make sure everything seems happy. So we're going to scroll up and make sure we have nothing highlighting in red. All good there, all good there. This is telling me that, yeah, the product will be null because we do have things that aren't valid yet. It's fine though. We're really fine with that for the moment. We don't have our set Lang yet. We're going to test that later. No reds there. Looks like everything's happy. So currently the system is happy. Part of the reason why it is happy, by the way, thank you. Hey, I'm bright again. Part of the reason why this is happy, even though we have none of these items being defined, except technically store has its definition here. That's the only thing that's actually being defined other than scanner, which actually it is not. So let me do that quick. Scanner. Dot in. And there we go. Forgot about that. The only things that are defined, that is definitely defined, is scanner and technically store will be defined once you instantiate whatever the item is. Now remember, I said instantiate, and that's why UI doesn't really yell at you yet or warn you that some of these are undefined, because nothing can be defined in an abstract class, and it's assuming that you're going to define these later. At the moment, you will get issues later on if you do create the child class and don't define these variables in some way, shape, or form. Make sense?
We're going to already have issues because you've defined them, but you have no data to.
That's what I'm saying. Yeah. Right now it doesn't matter because we can't instantiate UI, so we can't access any of these items really. The only items we can access is this static method right here, because of display options, because we can just access it through UI directly. Even though it's an abstract class, we can access it directly because it's a static method. Anything that's not static, remember, we cannot access unless we instantiate, and you cannot instantiate an abstract class. And just to prove that, we're going to do the import. I'm going to change this console here to K. And note how it tells us we cannot. UI is abstract and cannot be instantiated. So that's why the system isn't yelling at us for having potentially null or undefined properties yet. It's going to be upset if we have a child class that does not define them. All right. Let's build our English child class. So new Java class, English. And this, we're going to go ahead and do extends UI console, and double check, make sure you're reading the K console one. All right, it's now yelling at us saying we're not doing the default constructor. So go ahead and implement that. Restore, we're good. Now, the trick here is going to be whether or not we, and this is what I'm trying to remember the code for Java versus, I think it's C# or one of the other languages, whether or not we can define the fields up here, or do we have to declare them or define them in the constructor? And that's something I'm gonna try to see if I can, I believe I can do it up here. I'm gonna try it out. Anyway, superstore, that's fine. I'm gonna grab all my all these fields here, just these, the ones that we need to set. I'm going to paste them in here. And yep, it's not angry. And now what we want to do is we want to make sure that we override them and set them as final in this area here. Just to show that you can now. So you can turn all those variables we had now into finals. Copy.
Why don't you just replace them?
That might be easier. So this will be a fun one to do. So again, this is a little shortcut you can do. I'll highlight all this. Command R. What am I doing? Oh, right, that button. I'm going to do public string, just like that. And do public string and add final here. Like that. Look good? Make sure your in selection still set. Click replace all. And there we go. Now they're all final. And now they're all yelling at us that, hey, these might not be initialized. So now we're going to pull up our English console method so we can pull all these strings in. All right. All we need to do is grab everything after the return phrase. So the new string here, just grab all that. Copy, do equals, paste. That's what we're going to be doing a bunch of. So I'm going to have you guys just do it at your own pace. Do not need to follow me in time. If you want to, if you can copy paste faster than me, go for it. I'm just doing exactly that. Everything after the return statement, copying all that, and then pasting it into the field with the same name as the method. All right. So you can watch first, then do it. I'm going to give you guys a couple minutes to do it to catch up. So I'm just going to go through and do these quick. So that way they're done. Also, feel free to fix the indentation. How are you doing that? Oh, I forgot the equal sign. I'm being done. Equals new string. There we go. And return the string here. So just gonna grab the string. Copy that. That's our message. I'm gonna go to welcome here though. Paste. Menu prompt. Select prompt. Product prompt. We have cancel prompt. We got our error messages. Copy that all down. Product fields. String fields. And our fruit fields. All copied with our head in this level. That's going to be it. So I'm going to give everybody a couple minutes to catch up. Take your time to copy it over. Again, don't feel bad if you copy and paste slower than me. That's fine. I've been coding for a while, and I have blind type keyboard capabilities.
I have blind capabilities.
It's all good. It's something you can train, so don't worry about it so much.
Hey, Cliff,
Yes.
do we lose Hector?
That was a long time. Hector's been gone for a while.
Well, I
Yeah,
mean, I knew he was out, and then he came back, but he was behind a co-op. But I haven't seen him or heard from him. But I didn't know.
Hector,
what-
the student, right? The high
yeah,
school,
Hector
right?
he was with us.
Yeah,
he went to
Um,
Salesforce in the new year.
yeah. His parents ended up forcing him to go to college.
Oh, geez,
Yep.
that's a shame.
Oh yeah, we were ready to get him a job.
Yeah,
We
no,
were
he
gonna
was a
get him
really
one,
good
so.
kid, and he worked really well, and he did well in coding.
He was competent. In a couple more months, and he would have been fine.
Yeah,
He was doing good.
I don't feel bad. I liked him. He was a
Oh
good
yeah,
kid.
he was good. So for those who don't know, Hector was a high school student. We got him in while he was actually in his senior year of high school still, and he started career devs, which was really just cool to see. Good, helpful to teach, helpful to see, get his feedback on how we were teaching versus what he was learning in high school. And he definitely told us that he did feel like he was learning more in career devs than in school. So, and he felt confident that career devs was all he needed. He didn't need the college, but unfortunately, his family was very much, and a lot of families are like that. The idea, like college, we've been told this for years on end. If you want to succeed, you have to get a college degree. It's this prestige thing. It's what we're told. It's also kind of drilled into everyone. Like, if you can say your kid went to college, you've done good as a parent, right? There's a lot of like stigma to that and pride to it. I felt like we could do it, and there was a small part of me that was looking at like, ooh, this could prove that we can do this. If we can get if we can take a high school student and out of high school, get them a $70,000 job, that would be a great way to prove the ability of career devs, right? We could do that. That would definitely say, hey, career devs can do it. We can do what we say we can do. But unfortunately, the parents didn't support it, so he had to do it. So he ended up going to college. But
I went to college and I graduated taking up space.
there you go. That's the way to look at it. Anybody else need more time?
I could use another minute or so.
That's all I need to know. You just need to say yes. I don't need timing. You're fine. I don't need you feeling like you need to rush. I want you to copy paste correctly. No errors. Think about that. As long as you think about it that way, that if you take the time to copyright, you won't need to slow down class later by asking you to take a look at your code because you copied wrong. So take your time, copy accurately. Otherwise, you might end up taking up more time in the end. Don't be embarrassed by it. But yeah, no. Let's see. So I'm curious so anyone in the class, those who finish this, do we think we need anything else here to make this work? To see if we can utilize the English console as is. Because we know that you don't necessarily need a interface to work with things, right? The interface is there to help mask some of what's inside the class and to instruct another class what they can do and how they can use this other class. So as is, do we need to do anything else to this English class in order to be able to utilize it? What do you say? Any guesses? And you can even you don't even say what it is you think you need. Just a yes or no is fine.
I think we need to initialize the UI somewhere.
Sorry, what was that? I just saw a message in the chat. Sorry.
I think we need to initialize the UI somewhere.
Yes, we do need to initialize, or I wouldn't say initialize, but like instantiate it, right?
Yeah.
Yeah. But as the class, with the English class, do we need to do anything else in here? Is there any more code we need to add?
Oh.
Do you remember that time that I did the translate that I showed you, Cliff?
It was last week. My brain is a little foggy now.
Yeah. I did exactly how you're showing right now.
Really?
Yeah.
All right, cool. I can't remember that. Well, maybe that's why I realized I should have done this in the beginning. I was like, you know what? The abstract class works, and then we just use the interface, then tell the system what to do, what it can do, what methods it has.
That's what confused me, because like
Yeah.
for me, the interface was doing basically the same what I did with classes. So I was
Yes.
like, why do I need interface, you know?
Yep. yeah, again, as we get more into it, especially once we, and I feel like you'll definitely get an even better understanding of some of the use cases of interfaces when we get to Blackjack. You'll see a use case of an interface there with the actor class, the actor system. That'll definitely give a better understanding as well. But yeah, this is where we get. Yeah, if we have methods with logic that we want to, there's always this the main thing to remember is that interfaces, you should always keep in the back of your head, don't do logic. Interfaces just tell one class what methods exist in another type of class so that it can use those. The method doesn't need to know which specific class it's getting. It just needs to know that if it's this type of class, i.e. in a list, for example, like I said, a list is an interface. So what the list interface tells the class we use it in, what methods it has access to. It doesn't know all the other extra stuff that the specific list that it's given has or what it does. And this is also a great way to make sure that we protect our system from accessing methods it doesn't need. It simplifies the system, and it also allows our code to be swappable. We can accept any list if we implement a list. So while a lot of times what you guys have been doing is when you create a list field, you then tend to initialize a certain type of list. You definitely wouldn't need to either. You could after defining a list field in the constructor, accept a list as well, or a initialized list. So not one that has data in it, but just one that's already been initialized, like a new array list or a new linked list or a new tree list or stack list. You would accept that in the constructor and then put that inside of your list. And so again, you wouldn't need to know which specific list you were working with in order to utilize it. You could use it perfectly the same, perfectly normally, and you can take any list you wanted. But oh, that's cool, Colin. If you knew a little bit more about how to do the align things, the alignment stuff that like Haskell and stuff does. Nice. Very cool. All right, any more time?
Nope, I'm all caught up. Thanks.
All good? All right. So I didn't get much answers on whether or not we think we need to add more code to here. Last question. Anyone want to give an answer to that? Anyone want to take a guess? Do we need more code here?
I'm just going to throw this out.
Go for it.
This is a
Don't you
class.
guys, you should all have a
It's a class,
hypothesis.
right?
This is a class, yep.
You
And
don't have a
it-
constructor, but I don't think we need a constructor because there's nothing to construct.
We do. There's a constructor right here.
Oh, okay. All right. I didn't see it down
Yeah.
from there. All right.
It's a constructor that just passes the store to the parent class.
Yeah, okay. Yeah. All right. Oh, good. All right. I feel like there's something should be here.
It seems very empty, doesn't it? Yeah.
Yeah, it
So,
seems
no-
like it, but if you're just calling these methods, then you are just calling these variables, then I don't see need anymore unless you need to make methods on these variables. But you're already calling them from the abstract.
Hey, where'd my polls go? Poll system, where are you? Found it. Edit poll. Do. Yeah, it's very simple, just yes or no. Do you think that that console.english, so this class, need more code to work? I just want everyone to come up with a hypothesis. There doesn't need to be any reasoning behind it technically, but try to have some reasoning. Try to come up with a reasoning of why you think that answer might be true. So definitely you want to try to build as much of a hypothesis as you can. Launch that one. Launch it.
I mean, simply running it,
It is
we
launched.
would know, wouldn't we?
Yeah, well, yeah. If you don't do any more. Don't try to run it yourself and see if it works or not.
You
Just
spelled
have a
work wrong.
hypothesis. Have a hypothesis. Do not test it until you have a hypothesis first.
You spelled work wrong, but that's okay.
Oh, I did. I got an X in there. How did I get an X
Works.
in there?
It works. That works.
Definitely does. I don't know. Is that walks? No.
Walks, works, walks. Yeah. I
Mhm.
want to double. I want maybe.
Interesting.
I want maybe choice.
No maybes.
Maybe it needs it.
No maybes.
Maybe not.
There's 18 of us, but 2 of the people are not here, I think. So 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Hold on. Sorry. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 people here. I have 14 answers. There's 2 that haven't yet. Oh, there's 1 more. I normally would stop, but it's actually really close. Who's the last person who hasn't answered yet?
Christian? No, he's not part of the room.
No, so he's included in the total count of 18, but
David
I
too.
counted everyone here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I count 16 people in this room, not
Yeah.
including me.
And then you have Evan too, but just I know he's in a breakout.
Again, there's 18 total people other than me. 2 of them I'm not including, so it means 16 should vote. But screw it, we'll end it. Too late now. End poll. Share results. This is a fascinating one. We were 7 yes, 8 no, so unsure on this one. So I am curious, like anyone in the yes column, could you give me one thing you think might be needed? Anything you think? Just curious. If no one can, then fine. But I'm just curious if any of you can think of something you might think we need.
That's the thing. To
Did
me,
you make abstract the others on the UI?
None of the methods in the other one were abstract. No. If it was, we
So
would be getting
you
told that
can't
we have
override.
abstracts. Yeah. What's that?
So you can't override.
Right. Well, we don't need to.
Wait,
If there were
hold on
any
a
abstract
second.
classes here, English would tell us, hey, you have an abstract class that you're inheriting.
I know what you're missing. You're missing the constructor.
We've already said that. I have the constructor.
Yeah, but you don't have constructor for English. Oh yeah, you do. How come it's grade? Oh, because you haven't used it.
I haven't used it
I
yet.
saw it on the top. That's why. That's why I saw it. It was like grade. I'm like, he didn't make a constructor for that. I just saw a store.
All good. Just to showcase a quick abstract. An abstract method. Oh, right. And that. There we go. So an abstract method, now if I go to English and I take a look, we see that this is yelling at me because now we have a problem. English must either be declared, class English must either be declared abstract or implement the abstract method hello. So if you have an abstract method, that has to be defined, otherwise this class is also considered abstract. A non-abstract class cannot have abstract methods. Remember, all methods in a parent class are inherited. Every single method from a parent class is brought in and is owned by English as well. So we have, that tells us we have no abstract classes that we have to define. All the classes we have are valid. Any other theories? Anyone from the no want to try to articulate why they think no? Again, this is a thought experiment, so just take a stab at it.
Why are everyone so shy today?
And now I'm gonna start bringing up the wheel of doom.
I mean, no, I'm thinking no because I.
Can you repeat the question? I had to go to the bathroom. Sorry.
In 1 second, David. Let's let Sergio give his answer quick.
Go ahead, Sergio. Sorry.
Yes, sir. No, you're good. I was thinking no, just because I don't honestly don't know what else we would need here. I don't think it looks complete to me. But
Alright,
you know,
cool.
I could be missing critical information.
No, that's your theory. That's your theory. Go ahead, David. So David, what we're saying, like, so what was your answer, by the way, to the poll? What did you click on?
I had to go to the bathroom. I missed it. So
Did you put that in chat?
no, I did not. But go ahead.
Moving forward, try to
That's
do the
my fault.
BRB, just so that I know, because I was waiting for I was waiting for like a good minute for one person.
Sorry
to
about
answer.
that.
So, yeah, just
I
put a
had to
BRB.
go.
You don't have to tell us what you're doing.
Nature was calling. I couldn't.
That's fine. I don't stop you. Like I said, you don't need to tell me what you're doing. Just do BRB quick in the chat so that I know to be like, oh, there's someone not here.
Okay.
You don't need to tell me what you're doing, just that you're going to be right back. That's all.
I usually do. I just
Yeah.
the urgency was of the need. So what's up?
All good.
What's the question?
So the question here was like in our English, so console English method here, class, sorry.
Yeah.
Do we need any more code for this to work?
Well, if you redefined everything that you needed, technically no, but if you're extending, you've got the minimal requirements to make it work. But if you need it to work better, so to speak, you could add more to it, not take away. So currently, right now, no, unless if you have to redefine the methods.
And so here's the interesting thing. Remember, all these methods that we defined inside of the console UI are being inherited. So
Yes.
English technically has all these methods as well, right?
Yes.
And so we don't need to add any of these things, right? And the only method that our main class uses is this start method, right?
Yeah.
Which we set to public, which is inherited by English. So let's take a quick stab at this quick. We're going to switch this over to K-console, and we're also going to we're going to say new, not UI, but English now. We want to make sure we're using the K-console English, so do clarify that. So bring that one in. See how it's happy? Doesn't have any issues. We're going to use the start method, which is inherited through UI, and the UI tells us we have it because the interface, the abstract class is telling us we have it. So the abstract UI class tells us we have it. So we're going to use the start. And then we're just going to hit play. So play. Add an issue. Where am I? Shouldn't be null.
Leave the array length.
Is it pulling the fields out of itself and not pulling the new ones? Shouldn't be doing that. It should be pulling these, not these, but it is pulling these, isn't it? Yeah, these are showing up gray still. Don't do that.
Do you have to override them?
Should can I override a field? I thought it would.
It's an at symbol.
Yeah, no. Oh, you're right. Override.
With capital. Yep.
But that's from methods, I think.
No.
Mm.
Override out of the field. No, we can do this. I've seen it before.
Are the fields inherited though? I mean, from this class?
Fields are inherited. I'm just trying to override the existing fields because I have these fields. These fields are now belong to English as well, but it doesn't seem like it's overriding the original menu, even though they have the same name. So now I'm trying to remember what it is because it's super. Oh, hold on. Here's something we're going to test out now. Test out. We do.
You have to do English.start instead of UI.start.
Maybe, but I'm also going to try this quick little test here. We do welcome. Super, sorry. This is what I'm thinking is going on. That we have two different items. So we're actually accessing the parents. We're creating a new more local version of them instead of using the one we want. Do you have another way of fixing this technically? But I wanted it to do. I'll do a quick little check on this in a second. So I'm gonna pause the video, but didn't print when I wanted to print. Here quick. Turn off some of the back to main quick. All right. not gonna run start. We just want to do the constructor. So here we go. Oh, that's the item. Yeah, print. Yep, that's the menu, and then we do get null because we're accessing super. So we aren't changing the parent's item. Check again quick.
But if you're supering, don't you have to super all the variables across?
No, what I'm trying, the problem we're currently having though is that I'm utilizing these and I want this to take over that. So there's another way of doing it. I just didn't want to have to do it.
Do it.
Because I wanted this
Eats.
final. Because that means we're gonna have more copy paste again. So like that. And so we can put it all in the constructor, so that way the constructor will set all the variables. We would need to do this as well in the next class, which is not a big deal. It's just I was hoping to do it differently, but it's fine. But there's no shortcut to this, unfortunately. Cut, command backspace. Again, I am going to look at this again because I know there's a way to do this. I've seen it before. I've seen this.
So is it because you're calling the super that it doesn't see the overridden fields yet?
That's what I was thinking.
No, because again, it's saying so these are grayed out because they're not being used, even though they are being used by this. And I am
you
creating a
have to
new
pass that
localized
down?
version of this. So I'm creating a localized version of product fields. So
Yeah, but-
technically, this is technically not product fields, the field of the whole thing. It is English.product fields, while this is UI.product fields. And so inside English, when I do product fields, very similar to how we have product fields as an attribute and a method, we have, as you saw, we would have product fields, the method variable. We would have this.product fields for the class and super.product fields for the parent. And technically, if we had another parent, you can even do super.product fields if you had it going that deep down. And so your grandparent class could have the field, your parent class can have the field with a different definition, your personal class can have the same field with a different definition. So it's not.
So-
Yeah, that's what I was thinking, because like you're calling super, so it doesn't, it's like it's not accessing your overridden ones, it's just calling what was
Yeah.
defined, like quote unquote defined in the super.
Yep. So we're just going to do this. We now set the value instead of creating new fields. We're just going to set the fields for the interface. Sorry, for the abstract class.
But I thought the abstract class and all their fields are in the super that brings it down to the child ones.
Again, yes and no. It gives English access to it, and just like how we did with the parameter runs, if I ask for the phrase menu, it looks for the closest variable with menu. And so first it checks locally to say, hey, do I have a method named menu? No, I don't. Then it says, okay, do I have a class parameter, class field named menu? I do not. Does my parent have a class field menu? Yes or no? And so that's
Yes, the
how
parent does
that's
have
the
it.
scope. That's how the scope works in Java. So in this case, that's what's happening. Because the method that I'm calling is in the UI, remember you can't go down. So I remember that. So even though welcome is being pulled into English, this method doesn't know what the child class is going to have, and so it's going to use its own field that's the closest to it. And I can't. There's no way to access the child, so I can't say child dot blah. There's no child option. So again, I'm going to double check some of these as well again, do a couple more examples, but I knew it was one of these roots. I knew it was one of these. I just couldn't remember. I couldn't remember for the life of me which syntax it was. But this is correct. This does work.
They're just
Because
building a big constructor.
that's it. Yeah.
But you're not defining any fields other than the fact that you're just defining store. You're just adding these fields in directly.
That's what the abstract class does for us. The abstract class builds it all there. All of the subclass does is set everything. The subclass is going to set everything.
So he's
I
like
do believe,
setters.
however, I do want to check this now. I'm going to set all these back to public final though. So I do want to do that because that is something I do want. I do want these methods to be final. It's all it's telling me that they might not have been initialized, but they should be. Let's see if it'll let me do this. I think it should. Okay. Oh, wait, it's gonna yell at me because of the right here.
Well, could you make them final? I mean, could you
Why are
make
they
them
all,
protected?
why are they all red now?
Because they're final and there's a chance that they might not be defined.
No, in your
Oh, they're
constructor, they
public.
were all
Oh.
red too.
Yeah, hold on. That way they can't be accessed directly.
Oh, there you
Allowed?
go.
No,
Oh,
don't want that. There's no guarantee that the child class is going to do it, so it's fine. We are going to turn them into what is it? Protected now. We are going to turn them into protected. There's more I need to check on this. I don't want to do it in the constructor. That's not what I want. I don't want to put it in the constructor. This should work now. Yeah. Bing. Good. Back to main. Let's re-enable start. Play. I got a null. How do I get a null?
welcome. Supposed
What?
to say welcome to Cliff Store.
Yeah. There's welcome here. I don't have welcome. There's no
There you
welcome. All right, that's weird. I lost my welcome somewhere along the way. Here. Set that. That should work the way we want to now. So now everything should work the same it did before. We didn't remove this, unfortunately. Forgot to comment that out again. Oh, no, that's in here. That's why the handler isn't set, but it is here. So the handler's not there because we didn't make that method yet, but the options there, just don't select it because the handler won't do anything. Let's just do a quick thing. Let's do 3 quick. Make sure the code still works. So we do get the display. Add a product. Go ahead and add some fruit. What fruit are we adding? Jim got a fun one for us?
Cherries. Cherries.
Cherries? All right, we got a normal one
There
then.
you go.
What's the price of our cherries? Is it a box of cherries or is it a single cherry? Is it a bag of cherries? I don't know. What do they come in, bags or pots? I think they come in bags. Like grapes.
One cherry,
What's that?
just one cherry.
Single cherry?
Yeah, one.
No, I just need one. So
Just a single, just one cherry.
29 cents.
What is it?
29 cents.
All right,
You
29
guys check
cents.
yourself from a person who was charging you with a cherry.
There you go. And then our ID is going to be P 0, 2, 3, 4. I don't care. Inscription. Single. Hadness level. What's the hadness level of our cherry?
Hadness level?
Yeah, the hadness level.
yeah, you gotta forgive me. I wasn't there for the hadness part.
Goodness.
It's a typo that we just decided to keep.
Okay.
Manny, what you got for us? Is Manny here? Where's Manny hiding? Did we lose Manny?
You might be in the bathroom or
I don't know if that his I don't know if his
Yeah,
camera,
he
though.
put a BRB, I think.
Dang, I missed it. Oh, run in the bathroom real quick. He's there. So we don't have our hardness estimator here. So hadness stands for hardness.
Oh, wait, cherries are pretty hard, aren't they? They're crunchy.
I think so. What were you saying, Elaine?
I don't eat cherries, but I thought they were.
There's a-
pretty soft if you want them good. Like,
yeah, that's true. It depends. Again, I think it's the idea of like how likely can you squish it with just your bare hand?
Oh, yeah, you can
They have a
definitely.
pit also.
What's that?
They also have a pit, which is pretty
Yeah.
hard.
Yeah, so I guess we can give it like a 3, where it's not like super soft, like a, what was it, like a
A grape.
plum or something, or a grape, right, where you can squish it between your fingers. But you can definitely squish it. I think it's definitely softer than an apple.
Yeah.
Yeah.
Sure.
There we go. Let's go ahead and do 3. Let's see our cherry there. Good. I'm gonna go ahead and throw something away. What are we throwing away?
The milk.
Milk.
Bad again.
Mango.
All right.
Looks pretty gnar. Let's get
Always. It has been there for a while now. It's gone. Let's go ahead and sell one quick. What are we buying?
Orange juice.
All right, so we'll buy the D-002. Goes. Let's go ahead and double check the list of products again. And good, it's gone. Nice. Let's go ahead and quit now, and let's set up our change language. But to do that, let's go ahead and implement our next language, our Spanish one. So console, new class, Spanish. So using the English as a example, go ahead and try to do this yourself. I'm going to not share my screen during this time frame, so you guys can try to build this yourself. It shouldn't be that difficult. You're pretty much doing the exact same thing, just again, utilizing what you have available. You have everything you need. If you have my code from yesterday, from Thursday, give it a shot, and I'm gonna show it after we're done. So I'm gonna stop sharing for a second. I'm gonna keep working on mine, but you guys give it a shot. This is gonna be kind of a quiet part of the video. You know what, actually, hold on. Where's the pause button? There it is, again. So take a look at my screen quick. All you should need to do in this on the span is pull up the Spanish console item, and same thing we did before is put all the method fields inside of your constructor and just set them to the Spanish values. That is it. And of course, do the superstore. So, which sounds amazing. Superstore.
super.
It sounds like an official word. It's actually a thing. Superstore is a thing. So it's actually kind of fun. It rolls off the tongue nice. So we do these public Spanish store, superstore, and then we set all the variables again. And that's it. Nothing else of this is needed. And then once we go to main and we set our UI to Spanish, it works the same way, just with the Spanish text now, because we're using the exact same methods in UI. So I don't know what just happened there, but okay. There we go. Weird. All the methods are the same. We just chose to use the Spanish constructor instead of the English constructor, which sent different information over and overwrote all these fields. Make sense? All right. So one quick thing I do want to mention, by the way, we look through, we do know we have this public welcome, public display options, public start. We have the public get int on the UI on this thing. We have public void handle menu selection, and that's something we got to be aware of. Is we have all these items, these fields that are accessible, and so I can even do that and do UI dot look at all the items I have. Anything that's public, I have access to. So get int method, the handle menu selection method, the welcome method, the English, the equals object, which is not what I meant to do, but all those methods that I built that are public, I have access to. And this is where things can be a little difficult. And if I do build another UI later on, which is not console based, but let's say HTML based, I don't want to have to change and worry about what methods I have access to. I know that I want this start method. Really, that's all I want, right? Start method is the only method I should have and I need. And so I'm going to build a quick little interface. New Java class interface. We'll call this, actually spell it out, user interface. This is just going to do public void start. That is it. That's going to be our interface. We're going to head over to both our English and our Spanish. We're going to implement that item. Implements user interface. Now it's already happy because user interface just needs a start method, and user interface of English and Spanish already have a start method because of why. Why is it not upset? It needs a
It's
start method.
inherited.
Exactly,
Because-
it's inherited. Yep,
Well, it's also
No.
public, isn't it, though, too?
it's a public inherited method, yes. So that start method is already available in the English class. English class already has access to a start method that it can utilize. And so does Spanish. So now if I go back to main and I switch this UI to user interface now, if I do UI.start now, you see that those extra methods are now hidden. Only one we care about is the start method now. So now I can run the start. And so that's
run
the
both?
interface system. And very quickly now we can switch back and forth. So before we do anything else, so what I want to do next is now we need to consider, where does this belong? We can't switch the method now or switch the language inside of our console UI class, the English class, or the Spanish class, right? We can't switch what UI we're utilizing in either one of these, English, Spanish, or UI, because we're creating it and deciding which one we're going to use inside of main, right? Where else should this maybe go?
Shouldn't it go?
Where should this user interface maybe go?
Well, I would think it would go to the method that allows you to select language.
True, but where's that method go then? We don't want to add methods to the main, do we?
No, but all the current menu methods are in the abstract class.
Right? But again, that's not going to change anything because the abstract class doesn't decide what language it is, does it?
Right. Well,
Shouldn't it be in the UI?
Again, we're in the UI now, and this can't decide what language it's using. It doesn't know what language it's using.
No,
That's the key
I'm
item of the
sorry,
interface.
scroll back up. Abstract class UI.
The child class tells it what UI this is, what language this UI is.
Right.
Child class decides that. So let's see, is this a UI that I can bring anywhere? Is this a UI? Could I use this UI in Yahtzee?
Yes,
Oh, okay. Well, how?
I'm sorry?
Is this UI going to print out the display for Yahtzee stuff?
No.
No, right? I can't import this UI into Yahtzee, can I? I would have to make a whole bunch of changes, wouldn't I?
You would, that's what I was about to say, you have to make some changes.
So would it be safe to say that this user interface system kind of belongs to the store? Is that a safe thing to say?
It's a safe statement.
Anybody
Yeah.
disagree?
what belongs to the store?
Yeah, we could say that the store has an interface, a user interface, right?
Yeah.
We could argue that the store has a user interface. So now we go here to the store. Let's go over here at the top. I'm going to do, this is going to be a public item. User interface UI. I'm not going to set it right away. Brings it in on the console. We're good now. Now in our constructor, we can do that same method where we ask that initial item, right? We do that initial language set. So we go back to our, what was it? Our console UI with the C. Store over here. I don't know why it opened up there on me. There we go. Back at the top, we'll take that set lang. Right. Let's add that method here. Do language. We'll actually do it full out. Set language. And choice. Equals. Ooh, we need the int, right? So get int. What was special about get int?
Get int.
Yeah. Take a look at, let's look at our UI method and let's look at get int quick.
It automated the process
Okay.
for you to get the int.
Yep, but it isn't static. I thought it was static. Why is it not static? I thought this could be.
It wasn't
Error
static because
messages.
it wasn't static because you had it in the other one that because
Error messages.
yeah.
Right. So what I could do, by the way, is make this, because this should be static. I want to be able to access it. I just don't, I was being lazy Thursday. That was error messages 1, right? What was the number? It was 1, yeah. Double check that. Yeah, 1. Okay. To find these all. Really? I think we could actually do a more specific error message that if we wanted to, but we decided not to, just to make our life easier with this, but now it's starting to backfire a little bit. But we do want that to be there. The error messages should not be hard coded. That's just locking us in to making it a non-static item, and it should definitely not be, it definitely should be accessible externally. Now we can use it static. See? By doing this, making it a parameter, we now make it static, and it really should be, because we shouldn't really need to set this a certain way. So let's go back to our store now. We can do UI dot get in, but I do have a problem with this. If I do this, why do I have a problem with doing it that way? Using UI. Any guesses?
Well, you're limited amount of. Well, if you're doing the get in, you have to put an error message. Oh, well, get the error message in there.
You do that.
Yeah.
Wait, can I do this in Java? Ooh, you know what, actually, this might be tricky to know where I'm going with this one. I've imported user interface. If I want to use UI, I'd have to import user interface and UI. And I really don't want to have to import both. I should only have to import user interface. Now I'm trying to remember if an interface can do a static item. So let's find out. And we do need to get those parameters that it requires. So I'm going to jump over here, grab these. What is in there?
And a semicolon.
Oh, right. But it says it should have a body. Oh, right. You can define them here in the interface. So right now, I need to define them. You need to define it, huh? Well, that's true, because otherwise I would have to have an implementation of user interface. I can't do user interface dot get in if there's no body there. So I would have to give it something.
Is it supposed to be static on an interface or void?
You can.
Oh, okay.
But we just have to do this now. So we do that, and I can just grab the code here under getInt in here. Where am I? Here I am. Just grab all the code here. Basically, so in an interface, if you have a static method in an interface, it must be set.
And the scanner's not found.
Dang it.
And you can't declare anything.
Honestly, this whole process here, the reason why I have to do this now is because I'm now trying to correct what I did on Thursday. This is normal doing it like this. I'm just trying to correct my kind of haphazardly put together stuff on Thursday. So having static items in interfaces are common, because that way you can have access to them. So static scanner. Oh, I didn't import, right. Come on. In. So not in,
What,
right?
new scanner?
New scanner, that's what it is, yeah. scanner, system.in now. Now I have that. So now because I have this here, I can now do the user interface. Get it. Things in. So for language, we're going to have 1 and 2. So min 1, max 2. Our prompt. Okay, with this right here, remember? So I'm just going to grab this item here. And in this case, our error message is going to be invalid number in English and in Spanish. So I'm just going to go ahead and do on my console UI here. Not that one, sorry. Here, actually. I'm going to do invalid number here. Copy, store, paste. Slash. I got the Spanish version. Numero invalido. Store. I think that's something that kind of annoyed me. Oh no, it's fine now. Okay, good. And this now I don't want the find up there. So good. There we go. I'll give us that, and then we're going to bring in over this stuff. Grab that for a second. Paste it in. We're going to, of course, do UI equals new English. We got to import in English. So we can import console user interface. So hold on. New English from console now, not from C console, but from K console. And here, Spanish, K console, and UI. There's our change. And this needs to store. We're just going to do this. That's it. We're going to send it itself. Does that make sense? So far, so good. Any questions on that so far? Choice, we get the integer. We're going to set the UI to the user interface we want. I'm sending this as itself. I think, Sergio, are you trying to say something? Because you're breaking up, I think.
I didn't say anything.
Okay, I'm hearing like like someone's trying to speak, but it's not coming through.
Hmm.
So if you're trying to speak, type in chat.
Can you hear me now?
I can hear you, Sergio.
Yeah, you can hear me, right?
Yeah.
Okay. No, I haven't been trying to say anything.
What's
other
that?
than I haven't been trying to say anything.
Yeah, I heard that. I was just saying someone else was saying something. It wasn't you. Your block was lit up when I was hearing the come in, like someone trying to speak but not getting through. Like there's a
Maybe
flag in the thing.
it was my brain frying in this.
Oh. All right. There you go.
I am a loss, but I will catch up. Okay. Let me mute myself. It's making noises.
All good.
Incredibly.
I was just making sure I wasn't missing a question. That's all. So we're a set language method. And all we're going to do now, the last thing we're going to change up is right here under in our constructor for the store. We're going to run that as the first item. So we're first going to do set lang language, and then we'll do UI.start. Sound good? There's one downside to this setup that we currently have, though, is how do we change the language? Because the UI asks us to do something, but it can't access the UI outside of it. So that is one thing that's going to be an interesting challenge and something I didn't think of right away. So this is something that you might need to look into yourself later on, but it also can be something that we can do inside of store. Like I said, this ended up not being the perfect example, so I'm not going to get into changing the language mid-run. So all I'm going to do last to change it up quick is, for the moment, I'm going to remove the change language from our menus. I'm going to double check the method on how to add that back if we need to. I'm going to leave it as is. So I want you guys to kind of take this from as an example of another way we can implement an interface. Again, we're going to look at another system when we get to the blackjack cards. With that being said, we are at 7:30, right where I wanted to be. I don't want to go any farther. I want to give you guys like an hour and a half to work on your racers, get into your breakout rooms. You can do breakout rooms of groups. So you can get into groups of people, kind of work on them, maybe discuss what kind of interface you want to do. So you want to break out into a couple, like maybe for the first 30 minutes. If you want to just break out into 2 different rooms, jump into either room 1 or 2 and discuss any interface you want to build. If you aren't sure what you want to build other than language one, if you get an idea from somebody, kind of throw ideas around. Make sense? That's what I'm going to recommend you guys do first. And then for the last hour, jump into your private rooms or rooms of 2 or 3 most. Work on that stuff. Have your screen share in that situation, or when you're by yourself, you should have your screen share active. So if someone pops in, they can help you out. I'll go ahead and make Freddie and John co-hosts so that they can jump in and have full control. Did find out though that only the host gets the raise hand, by the way. So I did get a test. I did do some testing, by the way. So the raise hand only pings me, doesn't ping the co-hosts. So if you do want help you want to get some help from a classmate first, post it in Slack. And so everyone should make sure you have your Slack up and notifications on during class. I would highly recommend that notifications are on during class for your classroom channel. So you can see those requests for help, and that way anybody can jump in and help out. Not just those who are done or are TAs. Anybody can jump in and help. Hell, you can even jump in just to watch the help so you can learn from it. You might be able to learn something as well. So any questions on the assignment?
I saw a new feature on Zoom where in the reactions, you can also actually have a reaction that says I'm away. So instead of typing BR,
perfect. That'd be great.
You can just put that there and it shows up so that if someone walks in, they can see that.
Yep, perfect. Okay, so everyone take advantage of that as a reaction system. So even if then we don't need to use the chat. There we go. Slimer has it. The little copy symbol, and there's Freddy's. Okay, cool.
Oh, nice. I don't have to use my notepad with a Lenny face on it.
Now, does it stay there, or do you get to remove it when you're back?
Yeah, you can remove it by clicking.
So Slimer then removed it manually. Okay, I just saw Slimer's disappear shortly after you put it up. And I'm like, wait, did you do that or did it time out? Yeah, yours is still there, Freddie. Okay, cool. So yeah, you remove it yourself, right?
Yeah, it's a toggle.
Just added it. Nice, it's a toggle. It's like the raise hand system. Okay, so it's like raise hand because yeah, if you use the applause, that goes away over time. That's a click, it goes up and then it goes away on its own. But hands up and away are
the emojis are all temporary. The raise hand and the ones with like the lighter boxes are permanent.
Good, I like that. All right, cool. Yep, I see that one now. Awesome. Cool. So yeah, definitely play with those a little more. That'll help me out that way. Especially so this is a huge item for those of you who are unable to show a camera. And again, if it's because you have a broken camera, please let us know before we get to the end of this class because we need to get you a computer with a camera. Let us know. You need a camera for the interviews. So do not wait till then to let us know. Otherwise, you might delay your job acquisition because we're trying to scramble to get you a computer. So whatever your reason is, make sure we know. If your camera does work, then you're fine. But if you're not showing the camera, you have to use the reactions that I know you're paying attention, you're looking, you're there. Sound good? And really moving forward, I do have there is going to be a rule coming up that if you aren't showing the camera, and I do believe that you might be missing out on certain parts, I will start requiring the cameras for students. Otherwise, I'll be removing students from class when their cameras are not on without communicating with me. So make sure you're attendant, make sure you're paying attention, make sure you're responding and participating. As long as you're doing that, you're good. That's what I care about the most. And because I do know that some people their house environment is not set up for that as well. People walk around, significant others, kids, animals, whatever. But we want to work it out as best we can and make sure that when you do have the job, you are set up. Thank you, Colin. But no, that's the main thing I do. I know some home situations are a thing, and yeah, again, part of the reason why I now face the wall is because of my wife. So she does not want to be caught walking across the back of my screen. So part of the reason why I now sit like this with my back to the wall is for her. So I get it. I understand it. But yeah, we'll do that. I'm gonna stop the recording. Do that first. So we're good there. Wait, where's the recording? Stop recording.